Alright, now in this video, we're going to finally make a graph of circumference versus radius, or the diameter. I'm okay if you guys use diameter also. And then we're going to find some meaningful data. We'll do our maximum and slope, possible lines, all that good stuff. Okay, so first thing, I'm going to take these radii values. I'm going to highlight the column, control copy. I'm going to open in Excel, and just for my own benefit, I'm going to put the radius here, and then control paste. It'll auto-populate. And here we will plot the average circumference values. The reason you take trials is to minimize random error. So you never want to plot trial data for your dependent variables. You will only ever plot the average dependent variable values. So, whoops. Where are we? Right here. And I will come to this column, highlight everything, Control C to copy, and then Control V, everything auto-populates. We'll go to Insert. You'll insert a chart. Only ever insert a scatter chart. All of these other charts are no good for physics. You will insert a scatter chart, and you'll see things just kind of fill into place. But I do have the radius values on the x-axis is what it looks like, and the y-axis does look like my dependent variable, the average circumference. We're going to add some chart elements, axis titles, and we'll start there. So you'll always label your axis. This will be radius, and then you put the units, centimeters. Or if you've used the diameter, that's fine, /centimeters. We have the circumference, average circumference, and this is /centimeters for the units. So you always have the title, units, title, units. And we're going to give this graph a meaningful title. Maybe relationship between circumference and radius. Okay, and now I'm going to insert a trend line. So I click this green arrow or a check mark, and then I'm going to click this arrow to the side, and I will go to more options. When I go to more options, I might see this format trend line box pop up. I'm going to click these vertical green bars for trend line options, and I will scroll down to display equation on chart. And when I do, I see I get a nice equation with a y-intercept. That y-intercept would denote systematic error. That's something that is really hard to account for, really hard to control. It means that I had some inaccuracy in my measuring device, but it's still pretty small. To note that this is the line of best fit, I am going to actually format this box, and I would like to have a border in blue. By doing that, it lets me know that, okay, that's my line of best fit. So what this line shows and what I would need to explain in my IA, if this was my IA, is the fact that this shows a linear relationship, but it's not proportional, and this y-intercept denotes the presence of systematic error. I would need to analyze the slope as well. Before I do that, however, I will be adding, I'm going to go ahead and add a legend here, the way we can see, and I'm going to retitle this legend later. I'm going to add some error bars. IB expects you to show error bars for the data. Now for SL Physics, it's not as important for your horizontal error bars. However, if you do have uncertainty, just go ahead and add in the horizontal error bars. So I'm double-clicking the horizontal error bars, and we actually need to customize these because it's way too big. Customize them. I'll need to make sure I'm on Format Error Bars, and I'm going to click the vertical green bars, and I'm going to go to Custom, Specify Value, and I will delete this and click equal sign, and then the the uncertainty in my independent variable was 0.01 on both sides, plus or minus. So the positive error is the plus 0.01. The negative error value is the minus 0.01. So that'll run right and left. On the value. Okay, so equals with a bracket. Sorry about that. So you can see they are just barely able to be seen. Just barely there. But they are still visible. I will double click this and I will format now my vertical error bars. That's what it should read up here. Go into custom value, specify value, and it's not me to do that, equals with a bracket, 0.01. Same thing down here, 0.01. Okay. And you can see one of these data points is not in good agreement because it lies off the line. It mostly follows the trend, but to be safe, if I were actually writing the IA, I would note this deviation from linearity, most likely due to random error or with this measurement. Okay, but it's still relatively linear, even though this is line off the line, and ideally all 6 points, or at least the error bar, should be touching the line, but I'm just going to keep pressing on. Okay, now that I have the error bars up, I'm going to show you how to do the max and min slope possible lines. This will mostly work for almost all of the graphs that we'll make for the IA. If you have something special going on with your IA, I'll help you when we get there. We are going to make our maximum slope possible line. And to do that, really, this is a cheat, but I just focus on the two extreme data points. I'll be focusing on the data points here and then this data point here. But before I go on any further, I'm actually going to stop this video. I'm going to run out of free time on here and let you set up this graph like this, and in the next video I will show you how to do the max and min slope possible line. Thanks for watching.